So in the last class what we saw, it was that conversion to CNF formulas. Now what we are going to start is resolution works only on one thing that should be kept in mind is resolution works only on CNF formulas. Okay, so now we are going to write resolution algorithm. Okay, so what is resolution algorithm? Okay, so basically what it gives is that means how we are going to proceed is through contradiction. Okay, we are going to prove resolution through contradiction. Okay, so I hope you remember what is meant by contradiction. Contradiction से जो proof होता है उसका मतलब होता है कि we assume something that is not possible to be true, and then if we reach the conclusion that this particular statement is this particular assumption is false, then we think that we are assuming something wrong. So if we are having KB entails F, and this is bidirectional to KB union negation of F. Okay, what should be basically is KB should be able to derive F, but what we are going to assume is KB union negation of F, and we prove it that it is unsatisfiable. Then we can say that this is wrong and KB should be able to derive F, right? So the algorithm states the first step here as add negation of F to KB. Okay, so what we are going to do, we are going to add negation of F to KB. In the second step we are going to convert all formulas to CNF. Okay, we are going to convert all formulas to CNF form, right? And then in the third part we will repeatedly apply resolution rules. So we are going to apply resolution rules. Now return entailment if derive false. That means it should return entailment if it derives false. Entailment if derives false. Okay, so let us see one example. Okay, by one example it should be basically clear. So the example is let us say we are having KB is equal to A implies B or C. Okay, A implies B or C, and then we are given A, and then we are given negation of B. Okay, so we are given the negation of B. Okay, so what we will do here is we are given formula F is equal to C. Okay, so we are given this formula F is equal to C. Now what should be, we need to prove that whether F entails C. Okay, so what we will do, we will add negation of C to the KB, and therefore our KB becomes KB dash, and this is basically AB gives B or C. Okay, and then we are having A negation of B, and negation of C is also added to it. We have added it. Now we know that how to break this implication. So we can write here negation of A or B or C. Okay, then A, then negation of B, and then negation of C. So this is here. Now what we have to do is repeatedly we need to apply resolution rules. So if I take this particular part here, negation of A or B or C. Okay, so this is one thing that we are having, and in the second part I'm having a. Okay, so you know that negation of a and a will get cancelled as we have discussed, and then I will be having b or c, right? I will be having b or c, so I will be having b or c. And now if I start with negation of b, now if I start with negation of b, then b and negation of b should cancel each other, and I will be left with c. Okay, I will be left with c, and now I will be taking negation of c. I will take negation of c, and then if I will work through c and negation of c, I will be left with false. I will be left with false. Why we are left with false? Because basically this means you are doing c and negation of c. Okay, so basically what I mean is we are doing c and negation of c, and if c is 1 then it will be 0, if this is 0 then it will be 1, so this gives us false. that means since it is false, since it yields false, therefore we can say that kb entails c. Okay, so this is how we apply the resolution algorithm to prove something. Okay,